this section, we're going to talk about security concepts. If you enter into the computer security world, the first thing you will learn is about the CIA Triad. That stands for confidentiality, integrity, and availability. We're going to look at each one now. We'll start off with confidentiality. This can mean a few different things, but at the heart of it, what we're talking about is securing our data, and data in all forms. It supports the principle of least privilege, and what that means is that you only provide information to authorized individuals, processes, or systems, and you only provide enough information so that they can do their job, not a single piece of data more. Meaning when you hire somebody new, you don't give them full access to everything, to all systems, to all processes. Instead, you only give them access to what they need. If they need more to do their work, then you can review that and provide them with more access. But not everyone should be an admin. That administrator is only reserved for very few cases. Confidentiality also refers to encryption, and we want to keep our data secure and only readable by us and whoever else we allow. Encryption can be a whole topic in of itself, but in simple terms, it's about transforming readable data into something scrambled that can only be viewed by those who know how to decrypt the data with a password or a key or something else. The key part to encryption is that whatever we encrypt, we also have the ability to decrypt it. That means encryption is a two-way function. We can encrypt something and we can decrypt something. It can go both ways. This is important to remember for future slides. Let's look at an example of encryption. And again, this is going to be just a basic example. If you have a newer phone, you can enable encryption on it. And some of the newer phones have it enabled by default. This means that all of your data will be converted to scrambled text when your phone is off. When you turn it on, you have to provide a code or a pattern that will decrypt your phone data. If your phone gets stolen, hackers will not actually be able to read the contents on your phone. They may be able to plug it into their computer, but when they try to turn it on and view the contents, everything is going to be encrypted. They won't be able to read your contacts, your messages, or anything else that you have saved. This is if you have encryption enabled. Another very basic example of encryption would be talking in code. And maybe when you were a child, you had a secret language that you and a friend or a sibling spoke. You were able to take a word that you wanted and scramble it up into a code word, and then that person was able to decode that or decrypt it and know what you were saying or what you were writing. That is the basics of encryption, and it's a lot more complicated than that, but for this purpose, that's all we need to know. The other part of the CIA Triad is integrity. And integrity is the principle that information should be protected from intentional, unauthorized, or accidental changes. When we save our data, it should look the same when we retrieve it. We talked about databases earlier. When we save something and put it into a database, later when we retrieve it, the data should still be the same. It shouldn't have been modified by someone else without our approval. Not only that, but when we email someone, they should be able to feel confident that the email wasn't changed sometime between when it was sent from our computer and when it was received by their device. We want to make sure that in transit, that message wasn't changed. To do so, we need to use something called hashing. Hashing accepts an input message of any length, and it generates a fixed length output. Meaning if you only type in a few characters, you may get a fixed output of 256 scrambled up characters. Also, if you enter in 1,000,000 characters, that's also going to go down to 256 character output. When it comes to hashing, the most important thing to remember is that it is a one-way function. It cannot be reversed. There's no such thing as unhashing or dehashing. With encryption, remember, that's a two-way function. We can encrypt something and then we can decrypt it. But with hashing, it's a one-way function. Once an input gets hashed, it could never be unhashed. Because of that, we have hashing integrity, and we'll look at a simple example. I send you a message, but before I do, I want to hash it. And that hash may be 256 characters long, and it's going to be all scrambled up, letters, numbers, all different characters. You're going to receive the message hello along with the hash of my message that I sent. But when you read the message, your message says hey, not hello. When you hash that message, so you convert hey to a hash and compare it to the hash that I sent with hello, those two hashes are going to be different. Because they're not equal, you know that the message was modified in transit. This is called a digital signature, and most modern email platforms have this. You can search online for digital signatures to see how you can enable it on your email client if it's supported and learn more about it. The last section of the triad is availability. And what this means is that information is available and accessible to users when needed. In the IT world, we often think in terms of downtime. There are roughly 8,760 hours in a year, or we can say that's 525,600 minutes. And of course, there's leap years, but we'll just use these numbers. If you have a 99% uptime, meaning that you're only down for 1% of the year, that means that you were down for 5,256 minutes, or 87 to 88 hours, or 3.5 days, roughly. That's quite a bit of time for your system not to be available. Imagine you wanted to purchase something on Amazon, but it was only up for 99% of the year. That would mean there's almost 4 days where Amazon cannot take orders. That would be a lot of money that they're missing out on. A 99.9% uptime is 525 minutes and roughly 9 hours that you're down for the year. 4 nines, 99.99, that means you're down for 52, almost 53 minutes. And 5 nines, 99.999%, means you're only down for 5 minutes a year, roughly. That's called 5 nines, and that's often what IT companies try to strive for. You want to hit 5 nines. When it comes to downtime, one of the things we're concerned with is system outages. That's one major cause for downtime. This can be planned for maintenance or unplanned. And what we're concerned with and what we want to prevent is the unplanned downtime. That's when we're not expecting it and all of our systems go down. On the other hand, planned downtime often can't be avoided, as you should be keeping your systems up to date, which will require systems to be rebooted or restarted. However, you can plan to do these updates during off hours of the business. If your company usually works 9 to 5, you can do these updates early in the morning or late in the evening, or even on the weekend if it's a Monday to Friday business. You want to try to limit downtime, but you should not avoid it completely. Doing updates on your systems is incredibly important because often these updates correct security issues. There's also a reliance on the internet, and a lot of companies nowadays heavily rely on the internet, as do we as individuals. If the internet goes out, that can cause a significant amount of unplanned downtime. If you're a business that rely on the internet, you can have a redundancy line, which means you're paying for 2 different internet service providers, or you can ensure that you have a solid business continuity plan in place for when the internet goes out. Nowadays, a lot is connected to the internet. Point of sales machines, debit and credit card machines are all connected online. So having the internet go out of business can lead to problems. Even individually, as more of us work from home, if we didn't have the internet, we would have some issues. So you want to make sure that you have either a continuity plan in place to ensure that business can continue when something happens, or if you really rely on the internet, possibly have 2 different internet service providers.